Hi, we're going to continue discussing motor and mind. In our last video, we did an overview of motor development with a focus on manual development, posture, and balance, and we connected each of these to psychological developments. And in this video, we will look at locomotion. Locomotion is voluntary movement across locations, so moving your body from one place to another place. That includes creeping, crawling, cruising, walking, running, skipping, and so forth. One of the first steps in locomotor development is called the stepping reflex, and this is present at birth. It is genetically pre-wired. Do not do this at home, but well-trained researchers have placed newborn babies on treadmills, and that very slight stretch on the leg is enough to get babies' feet moving in an alternating pattern. Okay? The average age of crawling is about 7.5 months, although not all babies crawl, and the average age of walking is about 12 months. These ages are based on weird samples, so remember from Unit 1, white, educated, industrialized, rich, democratic. Cross-cultural research shows a much wider range of the emergence of locomotor skills. So cultures that provide a lot of opportunity and encouragement for free movement show earlier emergence of locomotor skills compared to cultures that provide constraints on infant movement. An example from American culture is the implementation of the Back to Sleep campaign several years ago. So parents were encouraged to put their babies to sleep on their backs as a way to reduce the incidence of sudden infant death syndrome. However, an unintended consequence of that is that babies were spending a lot less time on their tummies, and so they weren't developing the upper body strength that they need for many of these motor skills. And so now parents are encouraged to do tummy time with their babies very intentionally, since it's not happening as much as it used to just naturally. Okay? Another issue I want to mention here is dynamic systems. So recall from the last video that I said that motor development is not just a genetic blueprint that unfolds. It's much more dynamic and complicated, and there's a lot more variation among children. So, for example, walking. Walking is more than just stepping. I just said that newborn babies are born with a reflex to move their feet in a stepping motion. Actually being able to walk involves other component skills. You have to have well-developed muscles in the legs and the torso so you can have the posture and the balance needed in order to walk. There are motivational skills, there's perceptual skills, because walking involves moving you from one place to another, so you have to be able to navigate that effectively. Okay? So how does self-produced locomotion fundamentally change the way the baby learns about and understands the world? Well, in the last video, I said that reaching and grasping, later combined with sitting unsupported, allows the baby to explore the world within their reach. Locomotion allows the baby to explore at greater distances, so not only are they experiencing a lot of new things in the world, but they're encountering situations that demand better communication, and that communication needs to be at a distance. So I want to give you a couple of examples. So related to cognition, babies who crawl earlier quit making the A not B error related to object permanence. Those babies quit making that error earlier compared to babies who crawl later. Related to emotion. So social referencing is when a baby finds themselves in an unfamiliar situation and they look to a caregiver for information about what to do or how to feel. They didn't need to do that before, but now with locomotion, they're finding more and more need to gather information from the people that they trust. I first want to show you a clip That's going to show you something called the visual cliff. So pay attention. What is that? Does locomotion influence wariness of heights? And is it really fear of heights? And do babies apply their learning to different forms of locomotion?
Everyone has had some kind of an experience feeling something kind of like fear of heights, and it makes perfect common sense that we shouldn't jump over the edge of a drop-off because it's dangerous, and if it's dangerous, then we should probably be afraid of it.
Probably. Exactly how and when this hypothetical fear develops makes for pretty gleeful research inside Dr. Karen Adolph's lab.
We're discovering some surprising things that are flying in the face of, how people have studied locomotion for the last 100 years.
Including what babies do and feel when they're on a ledge.
So the story about fear of heights is that there was a very, very famous classical study in developmental psychology by Gibson and Locke in 1960 that showed that human infants and infants of a number of different species will avoid crossing over an apparent drop-off on what they called a visual cliff.
As soon as the baby can move about, he can be observed in the same way as other animals.
It's a glass table, and on one side there's a checkerboard pattern surface right under the glass. The other side of the table, the pattern surface is way down on the floor. So visually, it looks like a big 3-foot drop-off. So when human babies first begin crawling, most of them will crawl over the apparent drop-off, but after several weeks of crawling experience, then they'll begin to refuse to crawl over the drop-off. And the conventional interpretation of this was that infants are avoiding the drop-off because they're afraid of heights.
She's backing away very quickly.
No, she's not interested.
She wants no part of that side.
The experiment became the shaky foundation for the myth that crawling innately teaches us to fear heights.
Babies avoid going over the drop-off because they're afraid of heights. How do we know they're afraid of heights? Because they avoid crawling over the drop-off. So as you may have noticed, the argument is circular.
As it happened, the visual cliff was a better test of an infant's depth perception, not their fear of heights. And if you look closely, you may have actually noticed that the babies don't look particularly scared.
It is a perfectly safe surface of support. So after one trial, human infants cleverly figure this out, and then they will crawl over the drop-off.
So how do you really test if a baby is scared of heights?
You can test babies at the edge of a real cliff where there's no safety glass. It's just an actual drop-off, and the drop-off can be adjustable, so it can be little or really, really big.
And why stop there? Inside Dr. Adolph's Infant Action Lab, babies are tested on a variety of apparatuses.
You can test babies at the edge of a slope, so it can be steeper, 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 crossing bridges that are wide or narrow over a surface of support, and so on. If there's no safety glass, you can test the same baby dozens and dozens of trials in the same session. And that means that you can determine for each individual infant when they think that that surface is safe and when they think it's risky within a couple of degrees of accuracy, like 2 degrees of accuracy for a slope.
Dr. Adolph has spent 25 years running tests like these, and the resulting data sets are both convincing and adorable.
Infants spend most of each trial right at the edge of the precipice. They're reaching their arm down over the drop-off. They are putting their little feet or their little hands on the bridge and taking little tiny steps at the edge. And all the while they're doing it with either neutral or positive facial expressions.
What's more surprising is how their approach changes as they learn different forms of locomotion.
So what happens is that when babies first begin crawling, they'll crawl right over the edge. Then over weeks of crawling, their responses get more and more accurate until finally they're at adult-like levels so that they can tell precisely whether a slope is safe for crawling or whether a drop-off is safe for crawling. But then the next week, when these babies stand up and face these same drop-offs, same slopes, same apparatus, now as a new walker, they walk right over the edge. So in fact, there seems to be 4 learning curves in development as babies learn to sit, learn to crawl, as they learn to cruise, and then finally as they learn to walk. So if they were afraid of heights, you should just be afraid of heights. In the rain and on a train and in a tree, you shouldn't see 4 separate learning curves.
So if babies aren't learning to be afraid of heights, what are they learning?
I think that what babies are learning over weeks of sitting, crawling, cruising, walking is they're learning to perceive the relations between their bodies and the environment.
They're discovering what's possible and what's just a little too far.
And you can learn that without feeling any sort of fear at all. In fact, Eleanor Gibson, the person who first invented the visual cliff, wrote later in her life, as a goat is peering over the edge of a steep crag, it knows not to walk off the edge. And she said, I don't think it's feeling any emotions at all. It just knows not to go. And that's what we're seeing in babies.
Who probably know not to go. Probably.
Okay, so as you saw in the video and also in the image on this slide, the visual cliff is an apparatus that looks like there's a big drop-off. And there's a checkerboard pattern under half of it right below the surface, and then the checkerboard pattern on the other side is several feet below. But it's safe. There's a plexiglass or glass top that goes across the top. Nobody gets hurt. And when babies are either non-crawlers or they have just begun to crawl, they're not bothered by the drop-off at all. However, within a few weeks of learning how to crawl, they don't want to cross. And this has been interpreted in the past as fear of heights, but as you saw in the video, it's not really fear of heights. There doesn't seem to be fear, but rather babies are learning about how their bodies are moving around in the world. And as you saw through the work that Karen Adolph did, babies are learning these lessons when they're sitting, then when they're crawling, and then when they're walking. They're learning them over. They're not necessarily translating from one form of movement to another. Okay? Now, and it may not be fear, but it is certainly the case that babies see it as an ambiguous situation. And that is where this next clip comes in. So this clip comes from one of the laboratories that I worked in when I was in graduate school, and it's going to show you social referencing.
In this study, babies between 9 and 12 months are brought into the lab and placed on a large plexiglass top table. Half of the table has a checkerboard pattern just underneath the surface. But halfway across is a visual cliff, which the baby can tell drops off steeply. The plexiglass top continues, so it's perfectly fine to proceed. But the baby isn't so sure. And this is a big drop for a baby just starting to crawl. She wants to get across to get the toy, but she's cautious and looks to the opposite end of the table where her mother is. The parent is instructed to smile or make a fear face.
If the mother is posing a fear face, the baby typically does not cross this stair-step downward, this modified visual cliff or visual step. On the other hand, if the mother poses a smile or somehow poses a nonverbal communication that is not prohibitive but encouraging, the child is much more likely to cross over to her.
Okay, so as you saw, those were babies who had some experience crawling, and it's kind of like, I don't know what to do. It's an ambiguous situation. And so they look to the parent. And if the parent was posing a fear face, the babies would not cross. If the parent was posing a happy face, the babies would cross. So what the babies were doing, again, was social referencing, looking for information about what to do or how to feel. This is a very important form of emotional communication, and babies start to do it toward the end of the first year, in the weeks following the onset of self-produced locomotion. Okay, so something that you can do is think about, how do babies use toys? So how would a newborn or a 6-month-old or a 16-month-old use this particular toy? What are the gross motor skills, fine motor skills, cognitive skills that would be involved in this toy? And then reflect on other toys you've seen targeted at babies. What are the different kinds of skills that might be involved with those? Okay, so the big point of this lesson is that motor development has a very important relationship with other forms of psychological development. Okay, thank you.